Hello, class. Please mind the noise in the background today. Unfortunately, I've been exposed to COVID, and since I have that donor crud, I have to get tested because some of the symptoms align with that. So, this is a last minute video. Please mind the background noise, and I'll be back as soon as I can. As for the one period I'm going to have to do recording for, we're going to have to push that to Tuesday. All right, let's go. So, here's a warm up. Go ahead and give it a shot. We're just supposed to solve for y in this case. So it's kind of similar to solving for a variable that we've been doing the last few days, but we're going to be solving for y. So go ahead and give it a shot and resume it here in a little bit. All right. So welcome back. If you look, it's always a good idea to identify what you're after. So since we're identifying that we're after this y, we realize that we're multiplying by 3, but we're also adding this 2x. So we should probably take care of those. So let's go ahead and move the 2x over by subtracting it from both sides. By doing that, we help make it so it's easier to do the multiple division step without so many fractions. So when you do that, that's gone. We're left with 3y is equal to 6 minus 2x. From here, we just simply divide by this 3. All right? Dividing by the 3 causes this to cancel, leaving us just a y, and we have 6 minus 2x divided by 3. We could do the whole separation thing and break this up and have it be 2x divided by negative 2x divided by 3 plus 2, but this is okay as well because we just have that. Perfectly fine, perfectly easy. All right, so we're going to be looking at some literal equations today and formulas. So we're going to rearrange formulas and equations, highlight quantity interest, use formulas and equations to solve patterns. This is word problems and known functions. Today's going to be out of the books. I hope you guys all brought it today, so just so you guys as a reminder. So we have the warm-up, vocab, discussion, simple interest, distance formula, imperial versus metric, and then we're going to have to look at some triangles. So, isolate simple interest and variables should be reviewed. The new one should be formula and literal equations. We've been understanding what literal equations are the last few days. It's just equations with a lot of letters. The formula, we'll have a look here in a little bit. All right. So, simple interest formula. Solve the following formula for rate. Right now, simple interest is I, or interest earned, is equal to the principal times the rate times the time. So we want to identify what we're asked for. We're trying to solve for rate. That's the R. So we're going to identify what we're after and solve for it. So we're going to try to solve for this R by isolating R. Right now it's multiplied by the principal and the time. So we're going to divide that from both sides. Okay? So interest divided by basically the principal times the time will give us the rate. And we can just go and cross out some things here. Principal's gone. Time is gone. So R is equal to interest divided by principal time, or interest divided by principal times time is equal to rate. Both ways work. So it's just isolating. So you're probably asking, why do we want to rearrange it right now? We'll come to that in a little bit. Okay? So this is just a general understanding of what we're doing. We're actually given a known formula. So let us continue. For formula in math, it's a fact or rule written with mathematical symbols connecting two or more quantities with an equal sign. Equal sign, two or more quantities, interest, principal, rate, time. So, mathematical symbols. Notice it's not a formula does not include a lot of numbers. It's symbols. So it's something we've been dealing with for a little bit. All right. Let's continue. So the question is, what's the benefit actually of solving a formula for another term? We'll cover that in a little bit. The distance formula. Distance is written as distance is equal to rate times time. So suppose this is the only speed limit between us and just a nation of 365 miles away. We are pulled over and given a ticket. We made the trip in 5 hours, excluding the traffic stop. Was the ticket justified? Okay, so the distance we're traveling is 365. We made it in 5 hours, so we don't know our rate. So we could plug in the numbers we have and brute force it, or we can solve for rate and just plug it in easily. So let's just do it that way, all right? So distance is rate times time. And what we're going to do is solve for rate by dividing both sides by time. Time cancels out, and we're given distance divided by time is our rate. So let's plug in the values now. So we're going to take the 365, plug in for distance, and take the 5 and plug in for our time. So 365 divided by 5 gives us 73 hours. Or 73, not hours, miles per hour. So was the ticket justified? We were going 8 miles over, so we can say yes, because we were technically speeding the entire time. And there is a little bit of a gray zone with it, but it's not to that degree. So it's just manipulating the things and going for like that. As I said, please mind the noise in the background, and I apologize for that. All right? Let's continue on. So imperial versus metric. In the United States, we use what's called the imperial system, which uses Fahrenheit. Without using a phone, what is 40 degrees Fahrenheit in Celsius? Right now, this is the Fahrenheit is equal to all this Celsius. So we have to convert the formula over. So F is equal to 9/5 C plus 32. So we're going to subtract the 32 from both sides. So F minus 32 is equal to 9/5 C. And now we're just going to multiply by that reciprocal. When we do that, we're going to distribute the 5/9 now. And we can see that the 5/9 cancels with the 9/5. So 5 times whatever our degrees Fahrenheit is, minus 32, divided by 9, is equal to C. Alright? So it's just maneuvering things around like we were doing yesterday with the handout on the catch-up day. Alright, let's move on. Take the formula, kick it on over. Now we're going to take the degree, which is at 40 degrees, and pop it right on in. So 40 minus 32 times 5 divided by 9. So we're going to have 40 minus 32, which is 8, times 5 divided by 9. 40 divided by 9, which is about 4.4 degrees Celsius. So it's just a way we can easily put something in, plug something in, instead of plugging and chugging, and we rearrange the formula. We are able to plug it in and get it done really quick. That should be kind of a little bit more obvious now. You saw the steps we took just to get here, whereas we can just plug in the degree and get out lickety split. So you can see why messing with formulas might be a good idea. All right, let's keep on going. As I said, speed. So we have two triangles. I'm going to take this, pop it over here. Notice there's two of them. One has an area of 24 and a height of 8. The other has an area of 55 and a height of 10. Find the bases. The area of a triangle, and triangles are very popular in grade 2, is 1/2 base times height. So we have the formula to find the area right now. So to find the base, we just have to manipulate this. So let's go and do that. All right. So we're looking for the base, and the base is the blue one. So let's focus on that. Area is equal to 1/2 base times height. So what we're going to do is multiply by 2 divided by h. Because right now we're multiplying by h and we're dividing by 2. So we're going to multiply by 2 and divide by h. So distribute that through. Notice the 2's cancel and the h's cancel on the one side. So we're just left with base. So 2 times a divided by h, or 2 times the area divided by the height, is our base. So we maneuver the formula to the point where we can get the base relatively easily. So you'll see why this is effective, because if for a second we didn't want to go through all that and do brute force, this step would take a lot longer. I'm going to put that down here. So this is a reminder. Don't make things bigger unless you really have no choice. So we're plugging in our values. For the first triangle, we'll have 2 times 24 divided by 8. Before we make the number big, 8 does divide 24. We have a 3. So 2 times 3 is 6. Done. By manipulating the formula, we are able to get a way to get the base very quickly instead of having to brute force it every single time. Again, for the second one, 55 and 10. So just as a reminder, don't make bigger unless you have to. Let's rewrite it for a second if you don't really see what's going on. 10 can be written as 2 times 5. And now if you notice, we have a 2 above, 2 below, 55, 5. So those are gone, and we're left with just 11. We're done. So we could have multiplied by 2 times 55 to get us 110, divide by 10, get us 11, or we could have just reduced it this way. Now, if we went ahead and plugged everything in, for instance, the 55 and 10, we would have 55 times 1/2 times 5 is equal, times 5 is equal to that. And we would have gotten it anyway by dividing both sides by 5. But that was an extra step. Then we would have to do the same thing for this. These are pretty simple formulas, so it's pretty easy to see what we're doing here. But you can see the benefit of going through, changing the formula, so you go in, out, not have to really move anything around, because you already have solved for. All right? So 11 is equal to the base. As you see, today's classwork are these problems from the book. I will have it up momentarily as an online assignment as well. Sorry about this. Have a nice one. And a reminder, I'll try for the recording group, it's going to be pushed back another day because childcare issues. Have a nice one.